notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos, sections 1, 2, and 3. All 51 of those videos have been published on YouTube in their entirety. Section 4, measurement. Those 17 videos are completed, but only 5 are published in their entirety on YouTube. We are now at section 5, statistics. This is the 12th of 17 videos, and I am far behind schedule. Then, of course, we go to section 6, algebra. Section 7, relations, functions, and graphs. Section 8, geometry and trigonometry. Finally, section 9, vectors and matrices. This schedule is no longer valid. Disclaimer, this schedule was just a projection which now has to be adjusted. I have divided section 1, number theory and computation, in 33 videos. All of them are available on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. So 33 videos you see here. Please make good use of all of them. Another reminder, you need to know the times tables from 2 to 12. If you already know them, fine. If not, you will have to learn them, especially since calculators are not allowed in paper 1. As I just said, all 12 videos from section 2 have been published in their entirety on YouTube, and all 6 videos from section 3 sets have been published on YouTube in their entirety. Section 4, measurement, 17 videos. Out of those, these highlighted here in yellow have been published on YouTube in their entirety, and these others only partially. We are now at section 5, statistics. Before we go on, recall in the introductory video that I said you will need a good math textbook or maybe a set of 2 to get especially more practice questions. CSEC recommends the following, shown at right here. These. From those, please pay close attention to these 2 below here, since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course with CXC Questions by Raymond Tulsi. And this is a picture of volume 2. Disclaimer, I get no financial or other benefits from the sale of these books. Also, in late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only from paper 2. You can navigate by topics or years, where all questions for the past several years have been worked out. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely it will be explained for you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL of that website. RSC student. On the next slide, I will show you what the home page looks like for that website. This is the home page you see here. You will need to register first and then log in subsequently to that. This is the URL again. I will include that URL in the description of this video below so that you can easily click on it and be redirected to this website. This is a reminder that this formula sheet is provided for you during the CSEC examination, mathematics. This formula sheet you see here. There will be a link in the description below from where this formula sheet can be downloaded. Of course, if you have the syllabus, this sheet is in the syllabus. This is the top part of that formula sheet. Note, you do not need to learn or to memorize these formulae on this formula sheet. As I said before, this sheet will be provided during the examination. And this is the below part of the same formula sheet. As I said, you do not need to memorize these formulae, but you do need to know how and when to use these formulae. So we are at statistics. This is a print screen of the first 5 objectives in 7 videos, because this objective required 2 videos and this next one here, 2 more videos. We completed objective 6, we completed objective 7, and we completed objective 8 in 4 more videos, since this one took 2 videos. So we are now at objective 9, video 12 in this section. And then after that, we have a few more objectives to complete section 5. I have divided section 5 in 17 videos. That is 17 videos. We have finished up to here. We are now here, objective 9, video 12 in this section. These that you see here highlighted in yellow have been published in their entirety on YouTube. These others only partially published. When I finish this video 12, it will only be partially published. Note that this section is of particular interest, as you will have to make use of many of these concepts and principles in your SBAs. Especially if you are taking physics, you would have to do a similar profile which involves analysis and interpretation for your SBA. So you would have to collect data, you would have to analyze that data, often using a graph, line graph or otherwise, and then interpret that graph, extracting information from that graph, and also making projections from the graph. And it doesn't only apply to physics, but any other subject that you are doing SBA for. You will have to do analysis and interpretation. And not only that, but understanding these principles at the foundation of statistics is a necessary, even crucial part of life skills, so that you are not deceived by a one-sided argument using statistics. So as I said, we are here, objective 9, video 12 in this section. And it says, draw cumulative frequency curve, Ogive, and you are told to use appropriate scale for axes and use class boundaries as the domain. So recall from video 10 in this section, based on the second part of objective 5.7, where we had to determine the measures of dispersion of raw ungrouped data, and especially for group data, when we had to find range and interquartile range and semi-interquartile range. This was part B of that objective. In video 10, this was somewhere between A and B, but it was included in video 10. And at that point, I introduce you to the cumulative frequency graph, better known as Ogive curve or graph, or simply as Ogive. We said that a cumulative frequency graph, also known as Ogive, displays the running total of frequencies for each value in a data set. It helps visualize how data accumulates across the range of values and is useful for finding medians, quartiles, and other percentiles. So we looked at this as an example of an ogive. And I also mentioned then that the term ogive is derived from the French ogive, which refers to a pointed arch. Now you look at that and you may not see a pointed arch. Truth of the matter is you have half of an arch there. So this here looks like half of an arch if you take a mirror image of that and put it on the other side over here. Now you could see a complete pointed arch as opposed to a curved arch here. So ogive is a term used for this kind of graph, cumulative frequency. So as I said, this is an example. Note particularly that the cumulative frequency is always on the y-axis. Cumulative frequency here is always on the y-axis. And then the other variable is on the x-axis. Note that you do not need to begin the x-axis at 0. As you can see here, it begins at 100. So we are still reviewing what we did, because remember this is work we did before. At that time, I told you that we can choose the upper class limit, we can choose the upper class boundary to prepare this ogive. But now in this objective, 5.9, we are told to use class boundaries. So while we use that in objective 5.7, example 3b, for example, and we got answers that correspond to online calculator, 20 as the interquartile range, and this one here is 19, and so on, Q1 and Q3. And in that case, we were using the upper class limit. As a matter of fact, the online calculator use the class midpoint. I use upper class limit. The online calculator use class midpoint. And now in objective 5.9, we are told to use the class boundary. Not that it would make much of a difference, but we will use a class boundary. Class boundary. And here was example 4, when I use a class limit here, 139, and we use a cumulative frequency. Now we are told to use class boundaries. So in that case, when I use upper class limit, we got answers that correspond with the online calculator. So we are going to use class boundaries now. For this objective, we will modify those 3 examples we did in video 10, making use now of class boundaries instead of class limits. Note, this objective does not say anything about making use of this graph once you finish drawing it. All it says is to draw cumulative frequency curve, ogive. However, we already learned how to use these graphs in video 10, especially to find interquartile range of grouped data. 5.9, example 1. The group weight of 137 students with frequencies are shown in the table below. Construct or draw an ogive to show this information. So this is a table. We have the group weight and the frequencies. Well, the first step, we will include two other columns on the right with the upper class boundary and cumulative frequencies. So it looks like this. Upper class boundary, cumulative frequency. By now you know how to get cumulative frequency and you know how to get upper class boundary. Then we will draw two axes, labeling the y-axis as cumulative frequency and the x-axis as weight upper class boundary. So this is what we have here. As I said, we will draw the two axes, the x and the y-axis. The x-axis down here, the y-axis on the left there, and we will label them. This one here is always labeled cumulative frequency, and that one will have the other factor. Now, then we will appropriately scale the two axes. Now, if you look here, cumulative frequency, actually we are going from essentially 0 to 137, a little above that. So if we begin here at 0, let's do a trial run. 10, 20, 30, 40, 50, 60. No, we are going to run out of space. So let's try 20. 0, 20, 40, 60, 80, 100, 120, 140, 160. Yes, we could fit from 0 to approximately 140, 150 on this axis. Appropriately scale the y-axis to somewhat more than the total frequency. So we get 0, 20, 40. Equal distance must represent equal amounts. Okay, so we have the y-axis correctly scaled. Let's look at the x-axis now. We want to go somewhat more than the highest boundary. So we need to go above 84.5, so maybe 90. Down here, we can start at 0 and adjust it later on. So now let's see. If we start at 0 here, and that is 5, 10, 15, 20, 25, 30, 35, 40. No, we are going to run out of space. Let's go 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, that could work. So we scale it out like that. Now, what you see here, these initial steps are the most important in drawing any graph. What you see here, most important steps in drawing any graph. If you get this wrong, then most likely you will get everything else wrong that follows. So step 5 is to plot the points. I will spend a little time with this first one to explain this. So we have the points plotted. As you could see, this point here is first, second, the fourth point. First, second, third, fourth. Okay, so it is this one. 54.5, that's on this axis, somewhere here, 54.5 going up. And across here would be 47, somewhere there. But we need to be a little more precise than that. So let's spend a little time on plotting these points. So as I said, accurately plot the points. And to do that, you need to make sure that you know the sensitivity on each axis. For example, how did I get this point here, 64.5 and 92? How did I get this point here as 64.5 and 92? If you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel.